Hello, welcome to this lecture. In this lecture, we are going to talk about the types and the method lookup. Basically, we are going to start remembering how the lookup works. We are going to talk what are static types and how it reacts with dynamic types, how the type checker works in the middle, and how it affects the method lookup. So first, let's start remembering how the method lookup, how is resolved when we send a message. Sending a message basically is a two-step process. The first is to look up the method that match the message that we are sending and execute this method on the receiver. So every time we are sending a message, we have to start looking up the method to execute, and then we'll execute it on the receiver. Always the lookup starts in the class of the receiver. So we start, in this case, we have a colored rectangle that is colored rectangle class. We are going to start looking on it. If it is not in this class, we are going to go to the superclass and going to find it. We are sending the message area. We are going to find this, and this is the method that we are going to execute on the receiver. This was the original idea of sending messages, of having a message send based system. But the problem is that when I started having the idea of static types and static type checking, we have polluted this beautiful model. And now we have problems that how it works with the static type, what is a dynamic type, and how overloading works. Basically, we have to start defining what is the type of a variable. Yes, we have this simple program. We can see that a variable is a box with a label. It's a box that we can have a name and it references to object, but also it has a type. The type of the variable indicates what kind of object we can reference from it. So we can see it like a box where we can only put the type of objects that are of this type of the variable. We have to have an accord between the type of the variable and the type of the object that we are putting on. Of course, when we say the type, we say the type and its subtypes. Or in this case, for example, if the variable is the type A, we can put all the objects that are the class A and its subclasses. What is a type checker? Well, some object-oriented languages like Java, C# have a type checker. Basically, a type checker is a tool that in compilation time, before executing the program, just when we are compiling the program, will check to see if all the uses of a variable is congruent with the objects that we are putting on. We are trying to see if all the reference that we store in a variable has the correct type. With this type information, the idea is that we are avoiding to send unknown messages to a given object. So, to do this, the type checker bases it on the static typing. But we also have what is called dynamic types, that is the type of a variable during the execution of a program. In this case, we have the variable A that is defined to have a type of class A. The static type of this variable is class A. You can see here. And is assigned with this declared. The static type of a variable never changes because we say it explicitly when we declare the variable, and it will never change. The dynamic type, on the other side, is the type of the objects that are pointed by this variable A. In a given point of time, we can have that this variable A points to an object, an instance of the class B. In this case, for making it work and this to compile, B should be a subclass of A. So, in this point of the program, just in this point of the program, until we change the value of A, A has a dynamic type B because it's the type of the object that we are pointing. Yes, we have our variable A, and this is pointing to an object of class B. If we change the value of A in another part of the program, we modify more in the future of the execution, and now make it point to an object of type A. We instantiate a new object of type A and point a reference to it. Now the dynamic type of the variable A is the class A. In this case, we see that we can have the same static type and the same the dynamic type or not, but usually they should be equivalent. So it should be a subclass. In this case, to this be valid, B should be a subclass of A. We have our class A, and here we are going to have our class. In this case, it's important to see that they are different. And in most of our program, this is going to be what is happening. This idea of static types also affects the methods. In the languages with static type checking, the signature of a method, let's call it, if you want, the full name, the real full name of the method, includes the type of its argument. In this case, this is not the method foo. We can say, oh, well, yes, this is our method foo. No, in practice, this is the method foo that receives an object of type A as parameter. So remember that the signature includes not only the name, but also the types of the arguments of the message. This is important for the lookup, and we are going to see it much more in depth with an example. Remember that we can send the message foo that receives an object of class A with objects of instances of the class B also, because as I always say in these examples, B is a subclass of A. It's a subtype of A. So in this case, we are sending the message, and the message is sent correctly, but the static type of the variable A is always the class A, and the dynamic type is B. As before, we have a mismatch between them. This is important for the method lookup. We will see in the examples. Let's see that we have this little piece of code where we have two classes, again, class A and B, and we have two methods that are called M in the two cases, but one is receiving as argument an object of class A, and the other is receiving an object of class B. And then we have this little snippet of code that it will create two variables, A and B. It will declare two variables, one of type B and one of type A, and will assign both the same object. So we are going to have, if we have our diagram, have the variable B and the variable A, we are going to have, in this case, a single object B that is pointed by 2. Yes. Now the tricky question that you can take some time to try to answer to it: what are the results of all these invocations? What is printing on object? We are going to see it now in a second. Pause the video and try to find which is the solution for all of them, paying attention to the lookup. Well, these are the results of executing each of the invocations that we were saying. We will see case by case to see why is executing, why the result is what we have, why is executing this method in each call. Because remember always that static types determines which is the message that we are sending, yes, which is the signature of the message that we are sending, and dynamic types determines where we look for the method that responds to that message. When we have a static typing, we have two different types, and it's clear that we need to understand them correctly. We have a compilation stage and an execution stage. At compilation, when we are sending a message, we have to determine, the objective of the compilation is to know which is the message we are going to send. So the first thing that we need to do is to take the static type of the receiver. This is important, the static type of the receiver, to see in which class we start checking. Second, we have found this static type, we can now ask ourselves if this class of the static type defines the method that we are looking for with the name. And if it has this method by name, we have to see which is the best fit with the parameters that we have. With all this information, we are going to create the signature that we are going to use for the message. The signature, or we can say that we have our message. Then, when we are executing the program, we are going to use this message, the message that we identified, and we are going to do the lookup starting from the receiver. But basically, starting from the dynamic type of the receiver. Let's see the examples to show more clear what is happening. Again, we have the same extract of code. Remember, we are going to do it easily. We have this is static, and in the dynamic view, we have the variables A and B, and both are pointing to the same object that has dynamic type B. So, we have to see what happened here during the compilation and during the execution. We have the first steps are done during the compilation, and then we have the execution. We can divide again. This part is the compilation, and this part are the execution. So, the first thing that the compiler will do when tries to compile this expression is say, okay, which is the static type of the variable A? In this case, is the class A. So we are going to look, everything that we are going to look is from the class A and its superclasses, never the subclasses. Then we are sending the message named M. So we are looking for the message M in the class A. Oh, we have found one. Also, we see that the static type of the argument here is A also. See, the class A. So we have here a matching with the type. So we have identified that the message to send is that. And now, so we are looking for the complete name of the method that we are looking for is M with an argument of type class A. This is the signature that we have. So when we are in execution mode and we want to execute this code, what we do is say, okay, what dynamic type has the variable A? In this case is class B. So the lookup, we start from the class B, but we look for always the method that is called M for a class A. So we start looking our class B and we see, look, there is a method called M, but it's not the correct one because the name is not the full name, the signature is not correct. So this one, we don't want it. We continue looking in this case in the superclass and we find the correct method and we execute it, and in the console we have the correct value. Let's see this other example. We have a B in that has, in this case, we are going to test this expression. We have b, and we are sending the message m, passing as argument the little a. So in compilation, again, we are going to try to decide which is the signature of the method that we are looking for. So in this case, we are starting with the static type of b, that in this case is the class b. That is easy. So we are going to see the code in the class b and in its superclasses, in this case in b and in a. And we are going to look for the method that is called with the name m. In this case, we are going to find two methods that are called m, one in the class b and one in its superclass. However, we are looking specifically for the method, remember the signature and the full name, m, with the type a for its parameters. So the correct name that we are looking for is MAA. We check the compiler in compilation times. In the static checker, the type checker will check that there is a method. And yes, I'll say, yes, in the superclass, there is the method that we are looking for. So we can compile the method and eventually we are going to execute. When we execute our code, again, we have, in this case, the dynamic type of the variable b is the class b. So we start the lookup from this class. And we are looking for the method with the full name, with the full signature, m, that receives a class a as parameter. So in this case, we are going to do class b. Is there a method with this signature? No, this is not. So we continue looking up in the superclass, and we have found the one that we want to execute, and we execute, and in the console we have the correct message. Let's see this example fast, but it's interesting. We do the same. We have the compilation and the execution time, and in the compilation time, the compiler tries to apply the type checker and see, yes, this program looks nice, it's sound. So we start by taking the static type of the variable b. The static type of the variable b is the class b. Yes, so we are going to check again in the b and its superclass. We have found a method that is called m, so we need to know the type of the arguments of this method m. In this case, we are going to check the static type of the variable b, and we are going to see that is of the class b. So now the signature that we are looking for is basically m, but this name with a b, a capital B, with the class b. This program is good because all the objects that are of class b understand the message m with a b as parameter. So this is cool. We can compile the program. And now in execution time, we are going to do the lookup. The lookup starts in the class b because the dynamic type of the variable b is the class b, so it's cool. And we are looking for this signature. So we are going to find it here, and we are going to execute it and print the correct exit. Let's see this example. In this example, is exactly the same procedure. We have the compilation and the execution. The compilation will get the type of the variable a. In this case, is the static type is a, the class a. So we only look for in the class a. We don't care what happens in b. We have found that there is a method m. That's okay. We have found it. And here we want to establish which is the static type of the variable b. The static type of the variable b is the class b. Yes, but remember that we have a subtype between b and a. So all the objects of instances of b are also of the type a. So we will is the same that we would say that this variable B has the type class B and the class A. And as we are looking for methods with one or the other, we found the one with signature with the class A as parameter. So this is the signature that we want to have. As the compiler has found a solution, has found a method, a valid method, a valid message to send, this compiles good and we can execute it. And when we execute, again, as we have, remember that we have the two variables pointing always to the same object B, the dynamic type of the variable A is B, so the lookup starts in the class B, but we are looking for the method M with the type A. So the only one that we can find, because here is not the good one, we found the one in the class A, and we execute that one, and that one is what is printed. A final example that in this case will show a different situation is that imagine again we have class A and B, and we have a class C that is not related with any of them. We have A, B, this is a class of this, and we have class C here, completely out of the relationship, of the subtyped relationship. So when we want to compile this expression, we take the static type of the variable A, and in this case is A, so we start looking in the class A. We have found the method M, cool, but we need to validate that the parameter is the correct one. We have done before, but now we check the variable C, the static type, and this case is the class C. And if we see, there is no relationship between the class C and the class A, so we cannot use an object instance of C as an A. So there is no way of that this works, and this method is not valid. So the compiler say this cannot be compiled because there is no valid message to be sent. The examples that we have seen are really, really simple. You have to be very careful because static types get really tricky when you have it introduces new rules to the method lookup and can end in a strange execution and unwanted results. For more details, you have the lecture on overloading and interfaces that you can check, or you can recheck this video and check the examples slowly and following the steps one by one. The rules that we have seen in these examples are the ones that are applied, but in more complex examples, they are getting more complex itself, but are the same rules.